Guys, so we've reached the end of this monster chapter, so I'm going to top the playlist up with some exam questions, because we've learned a lot in here, so let's test our knowledge. So first up in this video then, we are looking through a hefty circle exam question. So, circle with centre C has equation x squared plus y squared plus 20x minus 14y plus 49 is equal to 0. Now part A wants us to write that in the form x minus a squared plus y minus b squared equals r squared. So, let's do just that. So first of all we're going to rewrite the circle equation as x squared plus 20x plus y squared minus 14y, and that is equal to minus 49. So I've reordered and subtracted the 49. Okay, now we need to complete the square separately on the x and y terms. So x squared plus 20x is going to give us x plus 10 squared minus 100, and then y squared minus 14y is going to give us plus y minus 7 squared minus 49, and then that is all equal to minus 49. So what we can notice there, both sides have a minus 49, so they can cancel out, leaving us with a 0 on the right hand side. So then finally we can get x plus 10 squared plus y minus 7 squared is equal to 100. So jobs are good. Okay, then part B asks us to show that the circle touches the y-axis and crosses the x-axis in two distinct points. So I'm going to split this up into part 1 for touching the y-axis, part 2 for touching the x-axis. So, for B part 1 then, let's show that it touches the y-axis. So when we're talking about touches, it means it doesn't cross. So, on the y-axis, x is equal to 0. So if we substitute that in, we get x is 0, so we get 10 squared plus y minus 7 squared, and that is all equal to 100. So, on the left we've got a 10 squared, which is 100, so we can take away 100 on both sides. That's going to leave us with y minus 7 squared is equal to 0. If we square root both sides, y minus 7 is equal to 0, therefore y is equal to 7. So, circle touches the y-axis at y equals 7. So that's the only point at which it touches the y-axis, so that is shown that it never crosses. Okay, then for part 2 of B, this time we want to show that it crosses the x-axis at 2 distinct points. So on the x-axis, this time y is equal to 0. So we substitute into our equation y equals 0. So this time we're going to get x plus 10 squared. So we're going to get x plus 10 squared, and then we've got, well, y is 0, so we're just going to get minus 7 squared, which is going to give us 49. And we know that that is equal to 100. So if we take away the 49, x plus 10 squared is equal to 51. Square root both sides, x plus 10 equals positive or negative the square root of 51. So x is equal to minus 10 plus or minus root 51. There are our 2 distinct points where the circle crosses the x-axis. Part C says a straight line has the equation y equals kx plus 2, where k is a constant. Part 1 is asking us to show that the x-coordinates of any points of intersection of the circle and the line satisfy the equation 1 plus k squared x squared plus 10 lots of 2 minus kx plus 25 is equal to 0. So now we're playing simultaneous equations. So our 2 equations here are the circle equation in red and now this blue equation of the line. So the line equation is telling us that y is equal to kx plus 2. So what we're going to do is substitute that into the circle equation, expand and simplify. So if we do that then, so let's just try and make it clear what we're doing. We are now using y equals kx plus 2. So where we've got this y here, we're going to put in kx plus 2. So we are going to get x plus 10 squared plus, well, y is now kx plus 2, so we got kx plus 2 minus 7, so that's going to give us kx minus 5 squared, and then that is all equal to 100. So now it's a case of expanding and simplifying. So x plus 10 squared is x squared plus 20x plus 100. And then kx minus 5 squared is going to give us k squared x squared minus 10kx and then plus 25 and then that is all equal to 100. Okay, so we've got x squared add k squared x squared. We've got 20x. We've got 20x minus 10kx. So 20x minus 10kx. We got plus 100, and then plus 25. So that is plus 125, and that is all equal to 100. So now we can go through and factorise a bit. So k squared x squared add x squared is going to be, or x squared plus k squared x squared is going to give us our 1 plus k squared x squared as we wanted. And then we can factor out the x over here and also a 10. So we can say we've got plus 10 lots of, well, we've got 2 minus k, and that's also got an x at the end. And then we can also subtract that 100, which is going to leave us with plus 25, which is equal to 0. So there is the equation that we wanted to show it satisfies. Okay, and then the last part of this monster question then wants us to find the value of k for which the line is a tangent to the circle. So if the line is a tangent, then we have 1 point of intersection. So that means the simultaneous equations that we just played with only have one solution. So we got those down to this form up here, so this lovely looking quadratic, and we want that quadratic to have only one solution. So remember the discriminant, b squared minus 4ac is equal to 0 when there is only one solution. So here then, we want b squared minus 4ac to equal 0. So if we substitute our stuff in, b is 10 times 2 minus k. So we want that squared, which is 100 lots of 2 minus k squared minus 4 times 1 plus k squared times 25. So 4 times 25 lots of 1 plus k squared. We want that to equal 0. So can we simplify this at all? Hopefully. So we've got 100 times 2 minus k squared minus, or 4 times 25 is 100 lots of 1 plus k squared. That's all equal to 0. So we got a common factor of 100, which is good. So we got 2 minus k squared minus 1 plus k squared is equal to 0. So if we expand out this first bracket, we're going to get k squared minus 4k plus 4, and then we've got minus k squared, and minus 1 is equal to 0, so the k squareds cancel out, so that's gone, and that's gone, so we've now got minus 4k, so minus 4k, plus 3 is equal to 0, almost there, so we can then say 3 is equal to 4k, and then divide by 4, 3/4 is equal to k. So that's our value of k that makes the straight line a tangent to the circle. And that's the end of this monster question. I hope you found it useful. Let me know if you want more examples like this.